So hi, in today's lecture we are going to see that how to reverse a linked list. Okay, so here they will be giving us an linked list which will be looking like this. Okay, so here we can see that we have 6 nodes. Okay, the elements are 5, 9, 10, 4, 3, 12. Now we have to reverse it. That means this node, okay, will be the first, this will be the second, this will be third, and so on. Okay, now we are not going to change any data. Okay, we are going to change just the pointing. Okay, that means, see, if this is a first node and this is a second node, that means this node should be pointing to 5k and this node should be pointing to 4k, this to this, and so on. And this node, since this node will be the last, so here we will be putting null. Okay, so the resultant linked list will be looking like this. Okay, so here we can see that this is the first node and in the original linked list it was the last node. Okay, and since this is the first node, okay, so the head will be containing the address of this node. Now this node is pointing to 5k, this is to 4k, 3k, and so on, and this will be the last node which will be containing null. Okay, so I hope you got this question. Now let's try to see that how we can solve this problem. Okay, now here in the question they are asking us that we need to solve the problem with the constant space. Okay, so we need to just play with the pointers rather than creating a new linked list and storing the values in the reverse order. So let's take, if I take this 3 linked list, okay, let's see that how we can reverse it. Now let's say if I'm standing over here, okay, that means the current node is pointing to 2k. Now I want to break this connection, and instead of this I will be pointing this 2k to 1k. Okay, now the question arises that if I'm breaking this connection, okay, that means the trail of this data will be lost in the infinity. Okay, so before breaking the connection I need to have one variable, okay, that stores the address of the next node. Okay, so here I will be taking the help of forward variable, okay, that stores the address of the next node. Okay, and since right now we are standing here, okay, so obviously the current node we will be having. Okay, now as you know that since this is a single linked list, okay, so if I want this node to point to the previous node, okay, I also need to have one variable which will be going to store the address of the previous node. Okay, so in short we will be needing 3 variables. Okay, with this 3 variable only we will be reversing the linked list. Okay, now the initial value, since we will be starting from the first node, the initial value of all these 3 will be null. This will be the head, okay, and this will be also null, the previous. Okay, now let's see that how we can try to reverse it. So forward will be null, current will be head, and previous will be null. Okay, now this will be done with the help of the while loop. So while, here it will be some condition. I'll let you know that what will be the condition. Okay, now let's take this thing. Okay, so if you focus here, the thing is that if I'm standing at the first node, okay, now this node should be pointing to the previous node. So here in this case, okay, it is simply null. Okay, now if I'm breaking this connection, okay, I need to store this node first. Okay, so I will be having forward will be current dot next, because obviously since I'm standing over here, okay, the current dot next is nothing but the forward node, right? So I will be storing this node in the forward variable, and then hence I can break the connection. Now after breaking the connection, I need to point this node to the previous node. Okay, so current dot next is equals to previous. So here in this case, since we are talking about the first node, so this node will be pointing to null. Okay, but let's see that what we have to do. Now I need to move further. Okay, so I will need to stand over here. Now since I need to stand over here, okay, I need to point this node to the previous one. Okay, that means, okay, before going further, okay, I need to store the current node as the previous one. So the previous will be current. Okay, now when I'm moving further, okay, I already see. Now let's see, I'm standing over here. Now when I want to move further, okay, I can't move it. Why? Because I break this connection. I have broke this connection, right? But this address is already stored in one variable. The name of the variable is forward. Okay, so current will be forward. Hence I can move from this to this. Okay, now let's see what will happen over here. See, here I need to store the address of the forward node. Okay, so I will be storing this address in the forward node. Okay, and after that I can break the connection. Okay, now I need to point this node to the previous node, and the previous node is this, right? So I can simply break this connection and point it over here. Okay, this is already broken. Now this is forward, this is current, this is previous. Okay, after that this current node has to be previous. Okay, so I will be updating this to previous, and since I need to move forward, so I will be having this node as the current node with the help of this. Okay, so that's it. Now the question arises that what will be the condition. Okay, I need to move forward, and I need to break the connection, and after breaking the connection I need to point that connection to the previous node. Okay, but there will be some time when there are no nodes. Okay, so when the current is pointing to null, at that time we need to stop it. Okay, otherwise we need to move forward. So the condition will be current is not equals to null. That's it. Okay, so with this pseudocode you can reverse the linked list. Okay, now if you want to talk about the time and space complexity, see, we are doing this for n times. Okay, and n means number of nodes. Okay, so the time complexity will be order of n. Okay, and obviously since we didn't take any extra space, so the space complexity will be order of 1. Now let's try to dry run it in the small test case. Okay, so this is the short test case. Okay, so as we know, the initial value of forward, current and previous, so the forward will be null, same as previous. Okay, and in current we need to store the head. Okay, so the current is this. Now here, since I'm standing over here, I need to break this connection. Okay, I need to point to the previous node. So here we can see that there is no previous node. Okay, so I will be pointing this to null. Now if I want to break this connection, obviously this data will be lost in infinity. Okay, so I need to store this 2k in the forward variable. So 2k is stored. Now hence the 2k is stored, I can simply point it to the previous node. So this connection will be disconnected and it will be pointing to the null. Now after that, since I need to move forward, so this node will be the previous and this node will be the current, right? So this will be previous and this will be the current. How we are getting this current? From the help of this, because we already stored the forward node in the forward variable. Now since I'm standing over here, I need to point this to the over here. Okay, that means I need to break this. If I need to break this, then this will be the loss in the infinity. So store, I will be storing this in the forward. So 3k. Okay, now 3k is stored. Now I can simply point this to the previous, and previous is 1k. So now I will be breaking this and I will be pointing to the previous node, right? And this is the forward. Now after making the connection, I need to have current node as previous and forward node as current, right? After doing this, I can see that the current is not null, right? So the forward will be the current dot next, that will be 4k. So the forward will be pointing to here now, right? Now I'm standing over here. Now I need to break this connection and I need to point it over here. So I can simply delete this connection and point it to this node, the previous node, which is 2k. Okay, now after that, I need to have current node as the previous node and forward node as the current node, right? Now again we can see that the current is not null. Okay, so I need to follow this step now. So here we can see that current dot next is null, right? So this will be pointing to null now. The forward will be pointing to null and the current is 4k and the previous is 3k, right? Now I need to point this node to the previous, so I can simply do that. So here we can see that the forward is null, so the current will be null with this. Now after doing this, we can see that the current is null. Okay, so we will be terminating the while loop. So here we can see that the linked list has been reversed. So this is the first node, this is the second, this is third, and this is fourth. Now the question arises that previously the head was 1k. Okay, now the head will be 4k. Now where the 4k is stored? The 4k is stored in the previous variable because previous is pointing to this, right? So we need to return previous. Okay, the new head will be the previous. Okay, so in this way you can reverse the linked list. So I hope you got this. The approach is very simple, okay, but it is for the first time. The understanding this, dry running this is a little bit difficult. Okay, so you can dry run it by yourself as well to get more clarity. Okay, so that's it from my side. I hope you got this approach. So I'll see you in the next video. Till then, keep practicing. Thank you so much.